So these are the basis of the starting point of our model development. So we're going to now have our first example on model development from our stock and flow diagram. All right. The first example that we're going to do here in this course, it's related to population balances. So a population balance is a number balance, and it is different from a balance of a mass balance, right? That has units, and in this case is related to the number of the population that we're describing. So our first example to understand how the models are constructed in Stella is the example of people in an island. So let's imagine that we have an island and we want to describe, or we want to follow the stock that in this case is the people on the island. So clearly we know, we can think about many flows, inflows and outflows that can affect these people on the island. The amount or the number of people on the island, right? But we're going to start with the basic flows that can affect this, which are birth and death. So people on the island will, the flows will be the birth and the death. But now we're going to consider another stock. In general, in environmental models, we will have more than one stock. And in some cases, these stocks are interrelated. So the people on the island, the growth or the increase on people on the island will depend on the island resources. So these island resources can be, for instance, food, or can be something that is needed for survival, right, of the people. So these island resources have two flows. One is the renewal inflow, and the other one is the depletion outflow. The value of each flow, or we can also call it of each process that is affecting the stock, is expressed as the amount of change it causes in the reservoir or the stock, because we know that we can also call it reservoir, in one full-time unit. So if the time is measured in years, then the birth flow will be expressed in units that correspond to the number of people born in 1 year. The death flow will likewise be expressed as the number of people that die in a single year. So these flows, the flows that are affecting each stock, imply an important set of equations that dictate how our model will calculate the future contents of the people in the island. So how whether these people on the island will increase or decrease on a certain amount of period. The simulation model will calculate the contents of the reservoir at each point in time, and now I'm going to try to explain how Stella calculates this. So what I'm trying to explain to you of the meaning of the change over time is that the future contents equals previous content plus all inflows minus all outflows. So how do we transform this into an equation? So we are saying that R, that is the resource, or the reservoir or the stock, let's call it a stock. So we're saying that the stock, whatever it is, equals, the time plus 1 of this stock will be equal to the previous content of this stock or previous size of this stock plus the sum of all inflows minus the sum of all outflows, right? So in general, if we wanted to predict the contents of this stock at a point in time, that is the delta time units in the future, we will use the following expression. So maybe you know where am I going, okay? So it means that S t plus delta t equals S t plus the sum inflows minus the sum of all the outflows, and this is multiplied by the time step, right? And then finally, we know that in this case, these inflows, the inflows are the birth and the outflows are the death, right? So this, if we move this one here, this just means minus S t, and if we move this delta t here, this just is equal to, well, first the delta of S, delta of t, which is, if we have the limits, it's the differential of the stock over time equals this part, right, without the t. So this is our differential equation on the first stock. All right. Okay. Now we are going to start analyzing in the stock and flow diagrams, and we are going to start adding the connections and the some converters that are also missing. So we know from before that birth flow is affected by the people on the island, as we discussed before, and we know that also the death is also dependent on the people of on the island, right? I'm going to decrease this. In the same way, renewal is also affected by the island resources, but the depletion of the island resources is not dependent on the island resources. It's an independent flow. So how are the people on the island and the island resources connected? Well, let's think about that. Well, if you notice, the people on the island will be the ones who deplete the island resources, right? So obviously we have a connection here. All right, but we also have other converters here, because if we will know, if we will have a flow of bird affecting this stock, this will be a constant value. Like it can be, we are having 3 people per day, 3 new people per day, increasing this flow. But it's not, in general, we don't have a fixed flow. What we have is a rate, right? So we can have a converter that is called the birth rate. In the same way, we also have another converter here that is the death rate. And these ones will rule these flows, right? Same way, we have renewal rate here affecting this flow. And in the same way, we have here another converter affecting the depletion, which is the depletion rate. Okay? We can have additional connections depending on the information that we have. So for instance, we can know that the island resources affect the birth rate. This can be a conscious decision of the community, of the island community, that dictate that they should reduce their birth rate in order to maintain a certain value of island resources. But it can also be a limitation that is somehow a depletion of the island resources may affect the birth rate because an increase of diseases or malnutrition, etc., of the population that will decrease the birth rate. Let's say that. We can have different connections, but remember that these connections will imply that here we have an equation that involves the island resources, and here we have an equation that involves the birth rate and the people in the island. Okay, so each of these converters, floats, and even stocks, well, stocks won't have equations, but the other ones will have equations or constant values. Okay, remember that the stocks are the accumulation component of an equation. So this is dP divided by dt, right? And this is equals to the flows in minus flow out, right? So in this case, we can have an equation, for instance, for birth rate, and this equation will be equal to the birth rate with a relationship that can be a multiplication with the people in the island, right? Because we also have an implication on the people on the island. Same way we will have for the death rate, but for instance, for the depletion, we can have an equation We don't know how, we just need to make sure that the units are consistent. In this case, the build rate has to, at the end, this one must have the units of number of people per year. So now you can guess what would be the units of the build rate, right? It has to be year minus 1, right? And in the case of the depletion, we don't know the equation, but we know that it implies people on the island. Well, we can call it, we can just call it P. And it also includes the depletion rate. Okay? But at the end, the units of depletion has to be island resources per time. But island resources can be, for instance, let's say kilograms of food per year. That means that somehow we must have units here that at the end give us the final units of kilograms of food per year. All right. So everything on each around each stop must have units that are consistent. Okay.